Today we are doing complex rational expressions. What's that? Okay. Nobody should be talking. Everyone should have notes out. Okay. So, you all can see that this is like a math student's dream problem. You have fractions within fractions. Isn't that awesome? Note the sarcasm there. Okay. So here we go. Here's how we're going to go about doing this. Jared.
Why not just change the decimal?
What is the decimal version of this?
I don't.
Y plus 1/2 y minus.
Instead of like having not instead of like 1/2 1/2.
Okay, because here's what's happening. We want to. Hey, Jonah J. We want to get to a place where we can simplify this. Decimals don't really work out very well for us in that regard.
Thank you.
Yeah. Okay. So how many people would agree? Let's put some parentheses up here so we don't get too lost. The numerator is y plus 1/2. The denominator is y minus 1/7. How many people would agree that y plus 1/2 is the same thing as y over 1 plus 1/2? Is that true? All I did was put the y over a 1. Any idea why I'm going to do that?
To make their denominators.
Excellent. To make their denominators the same. Everybody give it up for Marcy. All right. So what do I have to multiply y over 1 by to get the same denominator as the other fraction in the numerator? Yeah, Jared? 2. Everybody give it up for Jared. Okay, how about the bottom one? If I want the denominators to have the same 7. Okay, everybody give it up for yourselves. Okay, so nobody should be talking. So what we end up with in the numerator is y times 2 is 2y over 2 plus 1/2. Bottom we have 7y over 7 minus 1/7. So all we're going to do at this point is combine them into one giant fraction. So on the top we have 2y plus 1 over 2. Bottom we have 7y minus 1 over 7. Now, how many people agree that what we have here is one fraction being divided by another? Yeah? So am I able to do that whole same change flip thing? So this stays the same. We change that to a multiplication sign and then we flip this. Is that possible? Yes. Okay, so that's what we're going to do. Once we get it into one cohesive fraction in the numerator and one cohesive fraction in the denominator, we're going to do our same change flip. So the top is 2y plus 1 over 2. We're going to change that big division sign to multiplication and then flip the bottom. So it's 7 over 7y minus 1. And now this is where we're back to the same thing that we were doing before. Is there anything that can be simplified here? This is the point where we would look for any factoring that could happen in any numerator and denominator and then cancel stuff out. No. Lydia? Okay, you guys, can we do that? Can I just cancel these 2's out?
No.
No, why not?
They're part of a term.
They're part of a term, yeah. So remember, this is by itself. That's one unit combined, and same thing with this. So is there anything that I can do? No. So we're literally going to put them all into one giant fraction. I'm going to move the singular terms or the monomials to the front. So 7 times 2y plus 1 over 2 times 7y minus 1. And that is the end. Questions?
No.
Ashley?
So if we were to distribute it.
You can do that. You just don't have to.
Okay.
So if you were to distribute it to get 14y plus 7 over 14y minus 2, that's fine. Other questions? Okay, we have 2 more examples. Okay, next one. C squared minus 1 over 4c plus 4 over c minus 1 over c plus 1. Okay, here we go. Lydia? Okay, good. Let's get this so that it's not a division problem. In the last problem, we started out with 2 separate fractions, and we had to get them into one fraction before we did same change flip. This one starts out as one fraction, so from the very beginning we can just do same change flip, and then Lydia, I'm coming right back to you in just a second, okay? So same change, flip, and then when we do that we get c squared minus 1 over 4c plus 4 times c plus 1 over c minus 1. Okay, so now, Lydia was about to say what? Cool, everybody give it up for Lydia. That is a difference of 2 squares and factors to c plus 1, c minus 1. Anybody see anything else? Akashni. Cool, 4 and c plus 1. Everybody give it up for Akashni. All right? So for organization purposes, I'm going to rewrite this again. You all don't have to. You can just cancel out from that point. Organization is a good thing that we all could benefit from. All right, so things that can cancel. Haley.
The C minus 1s.
Okay, the C minus 1s. Good. Everybody give it up for Haley. What else? What else can cancel? Megan? C plus 1. Shh, does it matter? Can I do these or these? Does it matter? Nope. Okay, cool. Everybody give it up for Megan. So what am I left with as an answer? Cool. C plus 1 over 4. All right. So that one was super easy. Questions on that? You all are going to love the next problem. Okay, who is whistling?
Why does that sound like coming from over there?
It does sound like it's coming from over there. My first guess was, we all know who. Okay. All right. Here we go. Negative exponents within complex fractions. Okay, that's why I said you're going to love this problem. Why are we doing this? Last year, I think the response was, why is this necessary?
When am I going to use it?
Okay, here we go.
Is this going to be on the final?
Yes. Yes. Yes, it is. Okay, here we go. There's only one difference between this and the first example problem that we did. Okay, obviously that would be the negative exponents piece. So how many people would agree that x to the negative first is the same thing as x to the negative first over 1?
Why not?
Okay. Why not? So if we divide something by 1, that doesn't change it, right? Okay, let's put some parentheses. Okay, I'm doing this for a reason. Does anybody remember how we make negative exponents positive? Riley? Good. You switch them to the opposite side of the fraction line. Everybody give it up for Riley.
Yeah.
So you only take the components that have the negative exponents attached to them and you move those to the opposite side of the fraction line. So what this sort of morphs into is 1 over x plus 1 over y over 1 over x plus 3 over y. And now we're back to the same thing that we were doing before. So, on the top, what do I have to multiply this first fraction by so that we can get a common denominator? Y, good. And how about the second one? X, good. So y over y, x over x. How about on the bottom? Whoops. How about on the bottom? Y and x again, good. Y over y, x over x. Okay, so what we end up with is y plus x over xy on the top over y plus 3x over xy on the bottom. So now that we have one cohesive fraction, what do we do again? Same change, flip. Okay? Okay, so when I do that, I get y plus x over xy times xy over y plus 3x. Anybody see anything that can cancel? What? The xy's can cancel. So I'm left with y plus x over y plus 3x. Anything else that can cancel? No. But can't we cancel those y's?
No.
Why not? Kendra? Good. All right. Everybody give it up for Kendra. That's it. It wasn't as painful as you all thought it was going to be, right?
No, it was.
No, it was. It was. Okay. Well, at least you're honest. All right. There's your homework assignment. You managed to get it done in 10 minutes, you guys. That's really good.